J.
J, done.
Then 4 branches.
Boom, boom,
Like
boom, boom.
Y, Z, W.
X, Y, Z, W.
There's going to be 3 branches off of X, R, S, and T.
R, S,
2
T.
branches off of Y, R, and T. 2 branches off of Z, R, and S. 2 branches off of W, S, and T. All of them have partial derivatives on all the branches.
Partials everywhere, I love it. This is fantastic. So if I wanted to find the partial of J with respect to R, the person is asked here, basically what we're doing is we're just finding all the paths from J to an R, right? So here's one. And what's another one? Let's see, here's one right here. And here's one right here. And that's it, right? Just 3 paths. There's just 3 paths getting us to R. So do I need to include anything over here with the partial of J with respect to W? No, because W is not dependent on R, right? So therefore, any partial derivatives over there would just be 0. So what's the answer here? What am I going to choose? It's looking like partial J with respect to X times partial X with respect to R. Yes, that's the first one. And then we add that to the second path here, which would be partial J, partial Y, times, won't allow you, there you go, times partial Y, partial R, and then plus the third path, which would be partial J, partial Z, oops, times partial Z, partial R. Everybody okay with that? Does that make sense? Yeah? Great. And then the other 2 I am going to assume are totally similar. Just find the paths. Find the paths. Since we don't know anything about these functions, we can't do anything else, right? I have no idea what these functions are because I don't know what this function J is, but if I did know what this function J was, then I could do more work here. Is this okay for everybody? Thumbs up if you're feeling great about this, thumbs down, not as much. Thumbs somewhere in the middle if you're somewhere in the middle. Okay. Uh-oh, there's some thumbs down. It's Pegasus. Screw it. Screw it. Turn that frown upside down. Ah, there we go. Much better. Thank you. Okay. Let's try another one here. Suppose that G is equal to F of U minus V, comma V minus W, comma W minus U, and show that the partial of G with respect to U plus a partial G with respect to V plus a partial G with respect to W is equal to 0. This will be very similar to our homework problem. We started looking at the problem set this week. Anybody started looking at the problem set this week? Nobody? Oh, a few of us. Okay. All right, good luck here. What's the plan of attack here? Madeline, what do you do first here?
Well, I was first gonna draw, okay, I was gonna draw a tree with like U, V, W, V, or like oh gosh, I don't know. I just wrote down the problem. That's all I've done.
No, that's fine, that's fine.
I'm sorry.
No, you're good. So yeah, draw a tree. I think that's great, a great start. What are your branches for your tree gonna look like? Guess we'll start off with G, right? Everybody see the green okay?
Yeah, I was wondering about this. So if G is F of all of that stuff, I actually started off writing F, and then that broke off into U minus V, V minus W, and W minus U, and then from those I branched off with U, V, V, U, and W, U underneath them. I don't know if that's right.
So wait, you said you start with the branch, you start with the F as your base? And then what was branching off of F, what did you say?
Yeah.
What were your branches from F here?
U minus V, V minus W, and W minus U.
I see, okay. Yeah, I guess it's fine. I guess I would maybe call it still X, Y, and Z, though. I mean, there is no X, Y, and Z here, right? But if we think of
yeah, if X stands for U minus V, yes.
Right. Yeah, there we go. I think that's...
And then U and V, yeah, exactly, like that.
Okay, cool. just kind of like a silent X, Y, and Z here, right? Is everybody guys? Basically, I mean, throw in your favorite three letters as long as you don't use U, V, and W, I suppose. F is a function of three variables, right? So the problem here is that those variables don't have a name. Just name them, whatever you like. A, B, C is fine. Alpha, beta, gamma, whatever you want to do. I'm going to do X, Y, Z, but so our uppermost function is F or G. It doesn't matter. Use whichever one you want. But it's going to have three branches coming off of that because there's three components in that function, right? It's F of three things. And then each of those three things has two further independent variables. Is this okay for everybody? I think I might still call the top function G just so that it matches with what I'm trying to show over here. I'm trying to show that the partial of G with respect to U plus the other ones is equal to 0. So I'd like to, I think, to keep a G up there, but it doesn't matter. Okay, so what is partial G with respect to U here? Who can help me out with this one? What paths do I have?
I feel like
you see where it's going? Where's it going, Stomach?
it's going to 0 because right, you kind of have this case where, right, you say partial G, partial U, right? You're going to chain it to X, right, and Z. So then you do that again for V, and you change that to X and Y.
Yeah.
And then, what is it? And then, well, hold on, this one's right. So you do that, and so then for W, you go to Y and Z, right?
Yeah. You got some negatives in there though, right?
Right, but like, we know that dg, du, we know that these like U, V, and W is equal to these differences in F, right? It's equal to X, Y, and Z. So, 0.
Yeah, I hope you get 0. Yeah, that's what we're trying to show.
Right.
Yes, sir.
Okay.
Yeah, good. If you're getting 0, you're doing all the right things, son. Good job.
Okay. Nah.
True, are you feeling better at this? Sort of, kind of? Okay. So, help me out here. So, if I'm taking the partial of G with respect to U, I'm finding all the paths that get me from G down to U, right? And so the first path here goes via X. So I would have partial G, partial X, times partial X, partial U. That's the path on the left, right? And then we'd add this to the path on the right, which would be partial G, partial Z, times partial Z, partial U. Does that make sense for everybody? But what is the partial of X with respect to U? Who can help me out here? What's the partial of U? In other words, what is the derivative with respect to U of the first component there? What's the derivative with respect to U of U minus V? It is just 1. I'm seeing somebody typing in the chat window. That's just 1. Is everybody glad that? The first component there is U minus V, and so the derivative of U minus V with respect to U is just 1. What is the dg dz? I have no idea what that is because this function is not defined. But dz du, that means the derivative of the third, the partial derivative of the third component with respect to U. What is that? What is that? Partial derivative? Yeah, Alan?
Negative 1 is
Yeah, it's negative 1. Does everybody see that? Because you have W minus U here, and so the derivative of W minus U with respect to U is negative 1. Everybody buy that? And so then for the other two partial derivatives here, I'm assuming that you're going to get, somewhere you're going to get a positive, or excuse me, a negative dg dx and a positive dg dz, which will cancel each other out when you add them. And then you should be getting a positive and a negative dg dy, I suppose, if you did this all out. Does everybody see what's happening here? Is this making sense? Okay, so kind of from the get-go, the trick here is that x is u minus v, y is v minus w, and z is w minus u. And because the problem didn't explicitly state that we have these extra variables, so you have to remember to put extra variables in. Oh yeah, it's on it, clapping and loving it. It looks like a nice dramatic slow clap. I love it. Any questions on this problem? Thumbs up if you're feeling great about this problem. Thumbs down, not so much. Thumbs somewhere in the middle, or somewhere in the middle. No, sure, it's not happy today.
He's going through some stuff.
Okay, gotcha. Gotcha. Okay, so let's do, excuse me, an application of this.